Alright, what's up guys? So for this video, I'm just going to show you how to solve some of these more complicated word problems in CK-12 that require you to use those properties of logarithms, but now in real-world settings. So in this situation, we have a formula that gives us the loudness, the perceived loudness, or the amplitude of sound in relationship or as a function to the intensity of sound. So in this case, we have a few symbols we need to kind of understand before we use this formula here. So I'll just write it out. So we have Li, which again, as you can see here, Li is just measured in decibels, and it's the amplitude or the loudness of sound waves, right? And then I is the actual intensity, so the actual intensity of the sound, and then I naught, so this little zero means I naught. That's the called the human threshold for hearing. So basically, it's the lowest possible intensity, barely audible sound, which is on average about 10 to the negative 12th watts per square meter. So that right there is not a variable, that's a constant. We'll substitute the value for that in a second. So the variable here is I. I is the actual intensity of sound. And this question is a little tricky. It's asking you to find if the sound's intensity is tripled. So if we triple that, how much will the loudness change? So when we're dealing with a difference or a change in loudness, we need to find the difference between the tripling of the intensity and the actual intensity. So we're going to set up a difference here of these two loudnesses, these two amplitudes, and therefore we can use substitution to create the right side of this equation. And again, so our input here for this L function is 3i, so I'll go ahead and do that. I naught. And then we subtract Li, which is just right there. So we're just subtracting the original formula for the loudness of intensity I. Like that. All right. So what we need to do now is substitute the value we do know, which is right here. This is I naught. So this is that human threshold of hearing. So it's 10 to the negative 12. So I'll go ahead and do that. And then we can use the properties of logarithms to figure out this tricky little problem here. So we have 10 to the negative 12 minus 10 log I 10 to the negative 12. All right. So now what do we do? So we have to figure out what this is equal to, because this will tell us, well, how much of a difference does tripling the intensity, how much of a difference does that make on the overall loudness or amplitude? So even though this seems like impossible to do, it's actually pretty simple if you remember a couple of logarithmic properties. In this case, we have a difference of two logarithms of the same base. So what we can do is actually we can divide our arguments here. So if you remember, if we have a logarithm of quotient, it's just a matter of subtracting the individual logarithms of those different arguments, like that. So even though this looks all crazy and tons of letters and numbers and stuff, it's actually just this formula right here. So what we need to first do is we're going to factor out 10. So we're going to get 10 out the way. I'm going to make some space here. So we're going to factor out 10. And then we can use this property right here. And what we're going to do is take the quotient of this over this. So the logarithm, I'm going to have to make a large fraction here. All right, there we go. So all I did was I used this property, this quotient property of logarithms, and I took the arguments of this first logarithm and the argument of this logarithm, and I took the quotient of them. So this is the quotient. So essentially this is x and this is y. So I took x over y. All right, so again, this looks pretty ugly, but fortunately this is all going to simplify very quickly if we just remember when we're dealing with fractions. So in this case, if we're dividing, say we're dividing a over b so we take A over B and we divide it by, I don't know, C over D. Well, that's just equal to A over B times D over C. So if you remember from middle school, when we're dividing by fractions, we're actually just multiplying by the reciprocal here. So we can do that with this. And then you're going to see a lot of things start canceling out for us. So all I'm going to do is I'm going to multiply now this fraction by the reciprocal of this fraction. So we have 3i 10 to the negative 12 times 10 to the negative 12 over I. And now we can just, bracket, we can condense this by just multiplying straight across, and then you can notice with cross multiplication, well, these two I naughts cancel out. So technically we could have, we didn't even have to substitute 10 to the negative 12 here. We could have left it just I naught. So we're going to cancel out anyways, and notice the i's also cancel out. So what we actually have is just 10 log 3. And that's it. So in order to find, well, the effect of tripling the intensity here, and what's the difference between the tripled intensity and the original intensity, so we used a sequence of equations, and now we've come up 10 log 3. So what we can do is get this out the way, we can use a calculator, and then 10 log 3. So it's approximately 4.77 decibels louder. So in this case, again, they're asking for how many decibels more did the amplitude increase. When we triple the intensity, well, it's 4.77 decibels. And that's it.